Good now? Can you guys hear me in the back? Thumbs up? All right, cool. So we're going to go over Typescript, which is a programming language that is essentially built over JavaScript to cover any bugs that might happen because of wrong type usage. And in industry, you'll be using this a lot so you can create clean, documented, and safe code. So in JavaScript, we have primitive types: numbers, Boolean, strings, objects, undefined, and null. And types are important because there are certain operations that we can only do with certain types. For example, if we want to add two numbers together, we do 4 plus 3. If we want to concatenate two strings together, we do like string plus string. But we get undefined behavior whenever we, try to add a number and let's say like a Boolean. It's just not defined in JavaScript, and it doesn't really make any sense. And so in order to capture any bugs where like we add two types or do some operation that is invalid for two different types, Typescript is useful for catching those bugs. So JavaScript itself is dynamically typed, meaning that the type of a variable is determined at runtime. So we have this code here where we define a variable 5 and assign it the number 5. So at that instance in time, that variable is of type number. Then we move on to the next line. 5 is equal to a string 5. So then the type of our variable 5 is now a string. And then we assign it to undefined. So it's of type undefined. And so by the time we get into our console.log, we print undefined, and we don't have any kind of number type. And so reusing a variable for different types is generally not good practice. And so in JavaScript, you'll probably encounter a bunch of bugs because of this. So how do we make sure that this 5 is always a number? So we use Typescript. And Typescript is just a language built on top of JavaScript that enforces static typing. And essentially what Typescript does is it validates that your code works at compile time. So before you even run your Typescript or JavaScript file, you'll have like the little red squiggly lines telling you that, oh, maybe you assigned your variable to some different type than what you intended it to be. And this will save your life when debugging, especially when, because JavaScript doesn't really give you many errors. For example, like if you try to access some key in a dictionary that doesn't exist, you won't get a value or a key error as in Python. You'll just end up getting an undefined. And as these undefineds like propagate throughout your program, it's very difficult to find where your original bug is. And so, as I mentioned earlier, if we define our variable 5 to be of type number in Typescript, and then end up reassigning it later to be of type undefined, we're going to get like a red squiggly line telling us that undefined is not assignable to type number. And we cannot run a code, so we have to fix this before we actually run our JavaScript. And so here's a little meme about dynamic typing versus static typing. So essentially, the dynamic typing person, like, they finish their puzzle first, but it's a little bit incorrect. And then the static typing person is spending a little bit more time on the puzzle, but you know that by the end, when they finish their puzzle, it's going to be structurally correct. And a thing about this that is different from TypeScript and JavaScript is that even though you have static typing in TypeScript, that doesn't save you from all bugs, only bugs that deal with types. So I'll get into that later. So JavaScript itself, well, whenever we're writing a program, we write code in JavaScript, and then we run that code, and either we get an error or we get the result we wanted. For TypeScript, we write code, and then we constantly are statically type checking. So whether we get an error because we use the wrong type, it will be displayed by VS Code or TypeScript compiler. And by the time that we have no more errors, we can finally transpile our code into JavaScript, and then we run our JavaScript and we get either an error or the result we wanted. And so, as I mentioned earlier, TypeScript cannot cover all bugs, but it does cover a good amount of bugs that might take you a long time to find. And so if we have like all the code that you can write in JavaScript, and I mean all the wrong code you can write in JavaScript, then TypeScript will just be like a subset of that code. So it's constantly checking, helping you get rid of those bugs. Any questions? All right, cool. So how do we define types in TypeScript? So first, we can define a variable let x and define it as a string variable and then assign it to an actual literal string. Or we can not assign it to a literal string and just define it as string type. Or we can assign it to a literal string, and TypeScript will infer this and say, OK, our variable z is going to be of type string, and it won't change throughout the program. And so if we try to reassign x, y, and z to type number, this won't be possible by TypeScript, and we're going to have to fix that. So why do we care about static typing? Here are some examples of issues that static typing can catch. So first, missing or unnecessary prop values. So if you guys try to like make up your own attribute for a prop in JavaScript, you can. Like you can do like props dot like Among Us or something, and it wouldn't give you like an error or anything. You would just get like undefined or rather props dot Among Us would give you an undefined value. But in TypeScript, TypeScript will tell you, your props doesn't actually have an Among Us attribute, so you need to fix that. And whenever we pass down props, we can make our own prop object, and so we can clearly define what attributes are present in that prop. We can also catch similarly named variables or functions. In VS Code, you can easily like autocomplete to write your code faster. And maybe that might introduce some bugs that you won't notice down the line. So if you have like a function called callString and then a variable called string, if you try to assign your new variable newString to your function callString, you're going to get an error from TypeScript. And then we have undefined and null value behavior. So usually in JavaScript or TypeScript, whenever you want to define a variable to like have like no value, it's going to have a value undefined or null. But I advise against using null as like no value, because any type can be assigned to be a null type. Or rather, if you have a string variable with type string, and then you assign it to null, you won't get any, like TypeScript won't yell at you. And this is really bad because you can't do any operations on a null variable. So if you add like 3 plus null, like you're going to get an error from JavaScript. And so in order to actually catch whether a variable is representing something nullish, so either undefined or null, you can do this, it's called like nullish coalescing operation or something, which essentially just checks, is S a null or undefined? If it is, then you just return no string. Otherwise, you return the value inside of S. Yeah. And then overloaded operators. So JavaScript is really weird in that if I add a string 5 and 4, we're going to get, I'll show you guys. So if I pull up, I don't know, inspect, and then go to this console, and then I'm like 5 plus 4, I get 54 as a string. And so JavaScript overloaded the operator for addition so that we typecast 4 into a string and then concatenate it to 5. And so if we do this, or we end up doing this in a program, and we expect our value to like return, or rather our operation to return 9 instead of 54, then TypeScript will actually be able to catch this since we're expecting a number and not a string. And so Yeah. And these problems may seem obvious since like really small code snippets, but as you reach like more complex code bases, it's much easier for bugs to just like propagate throughout your whole program, and then it's going to be like a wild goose chase trying to find where your like small, probably like a typo bug is. And so it's really good practice to use TypeScript. Questions? All right, cool. All right, TypeScript with primitive types. So with defining a type in TypeScript with like string, Boolean, number, we simply put a colon after our declaration and then the type that we want to declare, and then we assign it to, in this case, a string. And because we can't reassign it to any other type, we get an error whenever we assign it to one. Whenever we have arrays of objects, we can either define it using like the object that is in our array, and then like 2 brackets, or we can have an array and then like brackets string. And if we want to have multiple objects in our array, we can use this thing called like the union of objects. So we can have like string or a number inside of our array. And then enums. Enums are basically like an object that we're creating, except it can only take on certain values. So here in this case, we set it to red, green, or blue. So whenever we define some variable to be of type color, those are our only options. And then you can actually define your own type in TypeScript or like in JavaScript. And one useful attribute that you can add is, or rather, you can use an optional parameter with a question mark so that only certain variables have this attribute inside of them. So here we have our user Kenneth, and Kenneth does not have an isAdmin attribute, but TypeScript doesn't yell at us. And then you can use types with other types. So here we have a user object, which is an ID and a name, and then the message uses that user object and a string, and then chat data uses a bunch of messages. So it's an easy way just to organize data whenever you have large applications. And so let's get into how we can type functions. And so the only like information that profiles a function is the input that it takes and then the output that it takes. I mean, the output that it returns. And so whenever we create a function signature, it usually looks like this in JavaScript. But we don't know anything about the ID or what it's returning. Like ID could be an ID type that we custom made. It could be a string. It could be a number. We don't know anything about it. And then we know that we're going to return comments because of the function name. But there's nothing enforcing that we return some specific type. So it could also be an array of strings or an array of some comment object that we make. And so if we transition this into TypeScript, we can define our ID to be of string type and then our array to be of an array of comments. And this basically ensures that we get what we want inside our function and we return what we want outside the function. And so TypeScript will yell at us if we don't return the correct thing or pass in the correct parameter. And then for async functions, it's essentially the same thing. We don't get any information about anything in JavaScript. But one difference is that whenever we return something through an asynchronous function, we know that our data that we're returning is going to be encapsulated inside of a promise. And so this is the syntax to return a promise of an array of comments. And then one thing I want to emphasize is how JavaScript and TypeScript treat functions as first-class objects. So what does that mean? So in Python and TypeScript, for a function to be first class, essentially means that we can treat it as a variable and pass it along to functions as input, or return a function as an output, or pass down a function as props. And this is important because, well, in your website, you're going to be passing down functions through props, and you're going to be using those as callback functions. And so getting into the, or realizing how we use functions as first-class objects is important. And the good thing about TypeScript is that it's easily integratable into your projects. So it works well with defining React prop/state types, and you can integrate TypeScript slowly/partially into your projects. You don't need to write your project entirely in JavaScript or entirely in TypeScript. And so I put some TypeScript setup info into the slides that you guys can look into later. And then I also have the skeleton in the slides in case you guys want to use TypeScript instead of JavaScript. Any questions? Yeah. Wait, sorry? I didn't hear the first part of your question. I think it's because people are lazy and people don't really want to write down like all the types for functions, and like it takes a lot of time to write a whole project in TypeScript. So like it's very easy for you to just like throw TypeScript out the window and then start using JavaScript. But it's really useful, and I think like in industry you'll end up like being forced to use it either way, and you'll get used to it. But yeah, since like you guys are barely learning, or barely learning like web development, it might be like a little bit intimidating to use TypeScript, but I highly recommend it. Any other questions? All right, cool. That's the end of the lecture. Please provide feedback if you liked the lecture, if you didn't like the lecture. It really helps. Thank you guys.